Okay, well, good afternoon, class. It's good to be here. I had to obviously videotape my project because, again, I'm going to miss class. What do you know? Missed it a bunch this year because of baseball. Anyways, let's get on to it. My major problem analysis, and if you guys don't remember me, my name's Sam Polensky. You guys might have forgotten since I haven't been there forever. But anyways, let's get on to it. My topic for my major problem analysis was to solve for the maximum value of negative x squared minus 3x minus 4. So I wanted to solve what the max height was for this problem. And I chose an algebra problem because algebra is my favorite math topic in all of math. So I decided, hey, why not do that since that's what I would enjoy the most. And so what am I going to cover? Well, of course, there's, we all know what all is involved in a major problem analysis, but with the time constraint, I'm going to focus mainly on existence, uniqueness, specialization, generalization, analogy, and then finish up with a couple duplicate solutions. So that's what I plan on covering today and in the amount of time that I have. So let's get into the problem. The existence. So what is the existence? Solving for the problem, finding the max height of the problem. If we do this, I took a table approach. There's other approaches that you can take. But if we do this, I took the route of just using table. And if we do this with only allowing integers, we get a max height of -2, and it happens at -2 and -1. So this was only allowing integers. A lot of times in math classes, students don't like working with decimals. So if we said, round to, or if we said only allow integers into your domain, we're going to find that at -2 and -1 we get a max height of -2. But what happens if we allow all real numbers into our domain? Well, using the table method again, if we understand what a quadratic function does, it's in the form of a parabola. We understand that it increases, and it's going to increase all the way to -1.75, and that occurs at -1.5, and then it decreases until -infinity. So we end up finding out that our max height of our equation occurs at -1.5, and the max height of it is -1.75. So existence, good. Okay. Uniqueness. So there are a few ways of going about this problem. I probably honestly chose the slowest way to do that. I don't know why I did, but probably one of the quickest ways, other than using a table, is just graphing it on a scientific calculator. Of course, that's no fun because then it does it for you. If we graphed it, we find that we would just, we put -x squared minus 3x minus 4 into our calculator, and then find out that our max height occurred at -1.5 when we used our calc functions, put them, ask for it to solve the maximum, and find out that it occurs at -1.5, -1.75. Another way of doing it, and honestly another really quick way of doing it, is putting it in a standard form. So if we put this equation in standard form, we get our a value and then our x minus h squared plus k. So we have to know where the max height is, but if we put it in the standard form, we get negative and then in parentheses x plus 1.5 raised to the second power minus 1.75. So if we were just given this, we would see that if we plug -1.5 into our calculator, into this equation, it ends up being 0, and then we subtract minus 1.75, and we get our height of -1.75. So that was a way of doing it. And then, is there only one answer? Well, again, it depends on what we allow into our domain. When we allowed integers, no. When we allowed all real numbers, yes, -1.5, -1.75. So that covers the uniqueness portion. So kind of what we were talking about earlier, specialization, putting some restrictions on it. Well, one restriction is what we already did, and I didn't even realize this until once I started putting my presentation together. We restricted the domain when we only allowed integers, and we cut off basically the entire set between -1 and -2. So when we allow only integers in our domain, we saw earlier that our max height was -2. Whereas if we allowed the set between -1 and -2, we found that at -1.5 it's actually higher at -1.75. So that was one restriction. And then what if we only allowed positive values into our range? Well, this yields no solution because we know that the max height is -1.75, so we can't get any values higher than that, and positive numbers are greater than any negative number. So we realized that our max height is -1.75, and if we allow only positive values into our range, it yields no solution. Okay, well, generalization. Now, what can we do to expand the domain or expand the range? Well, one quick thing that we can do is if we say add 100 to the function. So what does this do? It allows for positive values. It makes our max height 98.25. So this means that it starts at -infinity, increases all the way to 98.25, and then decreases to -infinity. So this allows us to get some positive values. Well, can we increase it any more? We'll just keep adding. So if we add 500 or 1,000 or infinity, for example, well then we can go all the way to -infinity to positive infinity. And then another generalization is if we just changed our function to -x cubed minus 3x minus 4, because if we did that, we know what a cubic function does. It starts at -infinity, acts like a snake, and then goes positive infinity, or vice versa. And so it covers -infinity and positive infinity for the domain, and -infinity to positive infinity. There you go. For the range. Okay. Next thing I wanted to cover was my two analogies, and I thought they were really cool. Everybody knows I'm a sports guy, so I found this picture. This is a picture of Yankees outfielder or catcher, I'm not sure what position he plays. His name's Aaron Judge. And I found this on Twitter while I was actually doing my problem analysis, and I was like, oh wow, I gotta use this. This is perfect. As you can see by the graph, we basically have what a quadratic function does. Let's kind of dive into this a little bit. So the first thing we notice is this little guy right here. He hits this ball at a 30-degree launch angle. Now, I found on a site that I will post later that to hit a ball at an optimal distance would be between 22 and 28, or so they found when they studied it. 22 to 28, and right in the middle, 25 would be probably the perfect, the best angle you can hit it at its farthest distance. So this was hit at a 30-degree launch angle. So he actually could have hit this ball even farther than 448 feet. He didn't need to, because obviously it went out of the park, and a home run's a home run no matter how far you hit it. But he hit it at a 30-degree launch angle. Now, of course, if we lower the angle, then the max height isn't going to be as high, whereas if we increase the angle, it's going to be higher. So his home run probably looked farther because it probably went higher than most home runs. So it probably looked like an absolute nuke. And then another thing to notice is that he hit this ball at an initial velocity of 116 miles per hour. So to give you a little bit of something to compare it to, I found that the average, or the highest average of an individual for his initial velocity off his home runs, or just swings in general, was 99.1 miles per hour. And this was by Miami Marlins slugger Giancarlo Stanton. He averaged 99.1 velocity off the bat. This guy hit it 17 miles per hour higher than that. So that was high, 17 miles per hour than the average highest individual. So that right there just tells you that this ball is an absolute missile. So he hit this ball, and it started at 160 miles per hour, 30-degree launch angle, up to 122 feet. And then, of course, it was in the air for 6.2 seconds, and then it went a horizontal distance of 448 feet. One last thing quick to understand is that the ball did not start at feet 0. It probably started about 4 or 5 feet, however high the ball was thrown. So that obviously helped the max height, a few feet. But nonetheless, Aaron Judge, he's an absolute slugger and a very talented baseball player. My second analogy, something also that was really good, was the arc of Steph Curry's free throw shot. So everybody knows that Steph Curry is just an absolute baller. He makes shots that nobody else makes. He's probably arguably the best shooter of all time. But this is just an arc of his free throw. And so the blue line is Steph Curry, and then the gray is like the typical 6'3" shooter, and then the black line is the hoop. So if we see right here, we have a couple stats. So his release angle is at a 58.1 degree angle, and then the typical 6'3" player is 54.6 degrees. So what this allows is, as I was reading up, it allows for when his ball hits the hoop, it hits the hoop at an angle at an average of 49 degrees, whereas the average player in the NBA hits it at 45 degrees. Now, of course, 90 degrees would be optimal, because if it hits it at a 90-degree angle, it allows for the max air to be greater. But that's obviously impossible. So what he does by his shot scientifically is he literally, as I was reading up, he literally makes the hoop bigger for himself. He gives himself a greater air, for instance. Some other few stats here. He releases the ball at 0.3 feet per second faster than the typical 6'3" point guard. And then his max height, which is what we're really trying to look at, is 13.5 feet, whereas the typical 60 player is 13. So shoots it a little bit higher, gives himself more room for air, and shoots it a little bit harder to kind of, if you shoot it a little bit higher, it has to be a little bit harder to still get to the same horizontal distance. But yeah, so that's Steph Curry. That's his arc. Guy's a maniac. Don't know how he does it. Wish I could shoot like him. We all do, because then we can make money like him too, right? Okay, and then finally, just real quick, duplicate solutions. One thing to know is that any function that is in the form negative x squared to an even power, so x squared, x fourth, x sixth, x to the 100th, minus 1.75 is going to yield a max height of negative 1.75, because obviously if we plug any value, negative or positive, into our x, it's going to be a positive value, and then when we apply that negative to it, it's going to decrease the function. So of course the max height occurs at x equals 0, and when we plug x equals 0 into any function, no matter what power it is, it's going to be 0, and then when we subtract minus 1.75 into it, it makes the max height negative 1.75. So that was just a quick duplicate solution. So anyways, that about wraps it up for me. Here are my sources. 5038.com was the where I found the stuff on Aaron Judge, and then Impredical was where I found the thing for Steph Curry. So that about wraps it up. Hope you guys enjoy your day, and of course, always go Mavs, baby.